Hello, children. This is Miss Radford. I hope that you are ready to learn and go up the mountain. Okay, so you have to give me some feedback and let me know whether you can see everything. This is my first video. Yay! So let's go ahead and go up the mountain. So the first thing is that we are talking about similar triangles. Similar triangles. Remember, similar triangles are not congruent. Everyone with me? Are they congruent? No. Similar triangles have a few things in common. Their angles are all congruent, but their sides are called something special that starts with a P. Do we remember? Yes, proportional. If you said proportional, then you are on track. So, similar triangles have congruent angles and proportional sides. So, how does this look if we only know part of the information? Well, as we have learned in class, there are different theorems that tell us whether we have similar triangles or not based on given information. So we are going to determine whether the triangles are similar. If so, we are going to write the similarity statement and then explain our reasoning. And that's very important for this step in our stage of development as young mathematicians, right? Okay, let's go up the mountain. So you see an example, number 2, and this one we probably went over in class. So let's go ahead and look at it again. So number 2, we see two triangles. What are some things that we notice about these two triangles? Well, one, I see that there's a right angle. Do you see that right angle? I hope you see it. It's the one with the little box in the corner. So both of these triangles have have a right angle. Both triangles are right triangles. So now we look at the sides. We see that we only have one angle to look at, so that may not be enough. We look at the sides to see if they are proportional, and then maybe we will have side angle side similarity. So that's one thing that I'm probably thinking it is. So let's check it, and maybe it is. All right, so we have to look at the sides that correspond to each other. So as I'm looking at this, I would look at 20 and 18. KL and WY are corresponding sides. So I need to see, this is what I'm going to check. I'm going to check to see if 20 over 18, give you a clean sheet of paper, how's that? So 20 over 18 is 20 over 18 equal to, do you remember what it was? I'll bring it back to the other corresponding sides, and that is 36 over 24. Now some of you may be able to do this quickly, but I will go over it in detail just in case we've forgotten how to reduce fractions. If you're a quick person, you can fast forward and skip this part and get straight to the answer. All right, so I'll reduce this as 20 over 18. Find a common factor between 20 and 18. 2 goes into 20 and 18. That sounds like a good choice. If you can find a bigger number, then use that. But when I look at 20 and 18, think I'm going to find out that 2 is it. So 2 goes into 20 how many times? You're right, 10 times. And then 2 goes into 18 how many times? If you said 9, that's it. So 10 over 9 is my reduced fraction for 20 over 18. Let's check 36 over 24. See if we get the same thing. So 36 divided by 24. Or if I reduce it, I will get what? I need a common number that goes into 36 and 24. Does 4 go into 36? Yep, it does. Does 4 go into 24? Yes, it does as well. Is there a bigger number that will go into each one? Think about it. Does 9 go into 36? Yes. Does 9 go into 24? Not quite. 8 does. That doesn't really help us, does it? So let's try 4. 4 goes into 36 how many times? If you said 9, you got it. 4 goes into 24 how many times? 6. Oh, look at that. It looks like, yep, we can reduce it again. So there was a bigger number that we could find in there. We'll talk about it in a minute. So what number goes into 9 and 6? If you guess 3, then you're right. 3 goes into 9 and 6. 3 goes into 9 3 times. 3 goes into 6 twice. Wonderful. So here's the question, and hopefully it is clear. Did we get something different? Yes, we did. 10 over 9 and 3 over 2. So are the sides proportional? I'm afraid not. They have to equal the same fraction once we reduce. If so, that would be our scale factor, and the sides would be proportional. So are these two triangles similar by side angle side? No, they aren't, and we just found out why. Our reasoning is, again, exactly. The sides are not proportional. Even though we have one angle that is the same, we need more information to let us know if the triangles are similar or not. With this information, we would have to say a big fat no, they are not proportional. Hopefully this helps. I'll talk to you in class. Keep going up the mountain. Do that homework. Signing off, Miss Radford.